Obtain all other zeros of 3x power 4 plus 6x cube minus 2x square minus 10x minus 5 if two of its zeros are root 5 by 3 and minus root 5 by 3. Here we are given a fourth order polynomial. For a fourth order polynomial there will be 4 zeros, but two of its zeros are already given. That means we need to find the other two zeros. See here, root 5 by 3 is a 0. That means x minus root 5 by 3 is a factor, right? If root 5 by 3 is a 0, then x minus root 5 by 3 is a factor of that polynomial. Similarly, if minus root 5 by 3 is a 0, then x plus root 5 by 3 is a 0. So if x minus root 5 by 3 and x plus root 5 by 3 are factors of this polynomial, then the product is also a factor. Therefore, if you multiply this, you get x square minus 5 by 3. So let me quickly repeat what we have done. So root 5 by 3 and minus root 5 by 3 are given as zeros. So if root 5 by 3 is a 0, then x minus root 5 by 3 is a factor. If minus of root 5 by 3 is a 0, then x plus root 5 by 3 is a factor. So if these two are factors, then the product is also a factor. So x minus root 5 by 3 into x plus root 5 by 3, that is x square minus 5 by 3 is also a factor of the polynomial. This is the most important step to move forward in this problem. So let's quickly do the next step. So since these two are zeros, x minus root 5 by 3 and x plus root 5 by 3 is also a factor. So the product is also a factor. The product is x square minus 5 by 3. So this x square minus 5 by 3 is a factor of the equation 3x power 4 plus 6x cube minus 2x square minus 10x minus 5. So once we get to this step, the remaining problem is very simple. Now if we divide this polynomial with x square minus 5 by 3, so we'll get the remaining equation for which we can easily find two roots because we'll get a quadratic equation. So now let's divide this polynomial with x square minus 5 by 3. So for that we'll again do using long division method. So in long division method, here the divisor should come. The divisor here is x square minus 5 by 3. And the dividend here is the polynomial 3x power 4 plus 6x cube minus 2x square minus 10x minus 5. That dividend comes over here. Now let's do the division. So the term with the highest power in this polynomial is 3x power 4. The term with the highest power in divisor is x square. Let's do the division. 3x power 4 by x square is equal to 3x square. Now multiply this 3x square with the divisor. The divisor is x square minus 5 by 3. So 3x square into x square is 3x power 4. 3x square into minus 5 by 3 is minus 5x square. So 3x square into minus 5 by 3 is minus 5x square. This 3x square should come in the quotient. And this 3x power 4 minus 5x square, write it over here. 3x power 4 minus 5x square. Again, be careful to group the terms with the same power. Let's do the subtraction. Change of signs. Plus becomes minus, minus becomes plus. 3x power 4 minus 3x power 4 gets cancelled. This is 6x cube. Minus 2x square plus 5x square is plus 3x square. Get this minus 10x down. Now we are left with another expression. Now let's continue with the division. The term with the highest power in this expression is 6x cube. The term with the highest power in divisor is x square. Let's do the division. 6x cube by x square is equal to 6x. Now multiply the 6x with the divisor. 6x into x square minus 5 by 3 is equal to 6x cube. 6x into minus 5 by 3 is minus 10x. Now this 6x should come in the quotient. So plus 6x. This 6x cube minus 10x, write it over here. 6x cube minus 10x. Again, be careful to group the terms with the same power. So do the subtraction. So let's change signs. Plus becomes minus, minus becomes plus. 6x cube minus 6x cube gets cancelled. Minus 10x plus 10x gets cancelled. So what we are left with is 3x square, and this minus 5 comes down. Minus 5. Now again, let's continue with the division. So in this expression, the term with the highest power is 3x square. Here in divisor, the term with the highest power is x square. Let's do the division. 3x square by x square is equal to 3. Multiply this 3 with the divisor, that is x square minus 5 by 3. So that becomes 3x square minus 5. So this 3, write it in the quotient. And this 3x square minus 5, write it over here. Let's do the subtraction. Let's change signs. Plus becomes minus, minus becomes plus. 3x square minus 3x square gets cancelled. Minus 5 plus 5 gets cancelled. So the answer is 0. So as you know, the remainder should be 0 because you know that x square minus 5 by 3 is a factor of this. Now we got 3x square plus 6x plus 3 as the quotient. That means if you multiply 3x square plus 6x plus 3 and x square minus 5 by 3, you will get this polynomial. So now we have 3x power 4 plus 6x cube minus 2x square minus 10x minus 5 is nothing but x square minus 5 by 3 into the quotient 3x square plus 6x plus 3. Let me take 3 common from this term. So that is nothing but 3 into x square minus 5 by 3. And if I take 3 common from here, you get x square plus 2x plus 1. Now we know that for this term the roots are root 5 by 3 and minus root 5 by 3. We need to find the zeros for this term, x square plus 2x plus 1. Now let's find the zeros for that term, x square plus 2x plus term. X square plus 2x plus 1 is equal to, let's split the middle term, 2x will be x and x plus 1. Let's take x common, x into x plus 1 plus x plus 1. That is, let's take x plus 1 common, x plus 1 into x plus 1. So either x plus 1 should be equal to 0 or x plus 1 should be equal to 0. Both are same. So if x plus 1 equal to 0, that means x is equal to minus 1 or x equal to minus 1. So the zeros for x square plus 2x plus 1 are minus 1 and minus 1. And we already know the other two zeros, that is root 5 by 3 and minus root 5 by 3. And the zeros of 3x power 4 plus 6x cube minus 2x square minus 10x minus 5 are root 5 by 3, minus root 5 by 3, minus 1 and minus 1. Therefore, zeros of the polynomial are this. So this is how we found the other two zeros. So what we did in this problem is, we found out that based on the given zeros that x square minus 5 by 3 is a factor of this equation. That's the one big step in this problem. Once we found out that, we divided the polynomial to obtain a quotient that is a second order polynomial. From that second order polynomial, we found out the other two zeros. So once we found the other two zeros, we have obtained all the 4 zeros of this polynomial. So that's how you solve this problem. I hope this is very clear. In case you still have any doubts, please let me know. Thank you.